Let me derive a formula here for kinetic energy, okay? And so for kinetic energy is the energy that this mass has when it's got some final velocity, right? And so the notion is that maybe this is our final velocity, right? And that the initial velocity over here, before we started moving it, right, was 0. And we push on it with some force for some distance, and the energy it gets, I'm going to use the idea that the energy it has is equal to the work that we did, right? So work is force times distance. Only now we're not lifting, so the force we're doing here is, F equals ma. We're accelerating it, right? So I'm going to substitute m times a in for the force, okay? Is everybody okay with that? Before I do that, I just want to make sure everybody's fine with that, because I wouldn't want somebody to get mad. Let's see. That's funny. Nobody's laughing, okay? I don't get this audience here. Okay, so that's what we've got, right? So it's going to be m times a times d. Now, here's the problem, is that this distance here, I know that I can make a substitution there using this formula, that the final velocity squared is the initial velocity squared plus 2ax, and our initial velocity is 0, so this guy goes away. This x here is our d, right? So our d really is equal to that velocity squared divided by 2a, right? This is a substitution, right? So I'm going to substitute that in for d, right? So that is m times a times v squared over 2a. And this is very cool, because the a cancels out as well. So it turns out it doesn't matter the distance or the force. These guys don't matter. It's the combination of them that matter. Really, all that matters is whatever that velocity is and whatever that mass is, right? That's what matters, because you end up with a formula that's 1/2 mv squared, okay? This is the formula all fancy and written out there, right? This is the kinetic energy in joules, velocity in meters per second, mass needs to be in kilograms. And you might want to pause here. Okay, write that down. Draw the pig's nose there. Okay. The one thing that's interesting about kinetic energy is notice that it's parabolic, right? So if we graph kinetic energy versus velocity here, right? And people lose sight of this when they drive, but this thing is actually a parabola. It gets steeper and steeper. The faster you go, every additional increase in velocity causes your kinetic energy to increase by an increasing amount. So if you speed up from, say, 20 miles per hour to 30 miles per hour, that's not as big an increase of your kinetic energy as going from 50 to 60 miles per hour. That's a much bigger increase. And they teach you that in driver's ed, I think. Let's do an example, and then we're done with this whole thing, right? And I made it as hard as we could. We put grams, so there's our mass, here's our velocity, right? Only for the mass, I think we need to go grams divided by 1,000, right, is equal to kilograms. So this is 0.0042 kilograms. And that's just fine. That's meters per second, so that's what we want, right? So kinetic energy is 1/2 mv squared, right? So it's 1/2 0.0042 kilograms times 965 meters per second, and that's squared. So 0.5, oops, got to turn the calculator on, 0.5 times 0.0042 times 965 squared is the answer down here. Okay, so that equals 1,955.5725 joules. Now we have about 3 digits here, so we could round this to this place, right, and say it's about 1,960 joules, right? Which is what I did down here. The other question you might have is a question about units, right? This thing intrinsically has the units of kilograms, right, times, and then this is squared, right? So it's meters squared per second squared, because the squared squares that and that, right? That's the units that we have. Is that equal to a joule? Right, well, remember, a joule, 1 joule is equal to a Newton times a meter, because work is force times distance, right? And then a Newton, remember a Newton is force, and F equals ma, so that's m is kilograms, a is meters per second squared. So a Newton is a meter, kilogram meter per second squared, right? And then that's times meters. And indeed, that's kilogram meters squared, right? Over seconds squared. So that's more than you ever really wanted to know, but these are clearly the same. All right?